speaker in this session is Florian Kraxner, talking about methods for locating sustainable BECCS. So, thank you.
Hello. So, good morning, everybody. I will run you through very quickly because this is the last presentation before lunch, and I myself very hungry. So let's see. I always argued here in my previous interventions that we have to show that we can provide, if we talk about BECCS, a sustainable system to the public, to the policymakers, and it's kind of our task from science to bring this up. So here is one suggestion, and I'm looking forward to a discussion on that one. I will provide some background and talk about the environmental and sustainability issues, show quickly our modeling approach from IASA, and talk about the integration of these two factors here, and show how it looks like at the test case of US, and then come up with the conclusions. Mentioned before and in many excellent keynotes here, actually all negative emissions are criticized in some way that we have seen impressively. And bioenergy with carbon capture and storage is actually something that is considered quite mature. However, it is also heavily criticized. One, for we don't know how much we need, and we don't know how much land we need in order to provide it. And secondly, of course, because of its potentially negative impact on factors like biodiversity, etc. Now, for this study, we assumed that we probably need negative emissions, and if we need negative emissions, we picked the BECCS case here, and out of the BECCS options, so biomass plus CCS, we are looking at the forest-based biomass system. And if we agree to all that, we need to show that we can do that in an utmost environmentally and sustainable way. And how our idea looks like, I will show a little bit. But first of all, a little reminiscence to Christian Assar, who is also one of the spirits of this conference, I assume, and quite some time back in 2010, he made a comparison between different models who came up at the end of the century with quite some large share of biomass that it is needed, and parts of that is also biomass plus CCS, and it was in the range of 200 to 300 exajoules here. So this was 2010. And looking back at what has been presented yesterday and the most recent study, this meta-study from MCC, we see that first of all, the range from back then is very much okay. It's between 100 and 300 exajoules. But the interesting thing is that no matter if we now do BECCS or not, there will be, or the models project that there will be a lot of need for bioenergy, and even more if BECCS don't come through. So this is interesting, and this is kind of the motivation why we need a sustainable supply system here. The question is, where do we take it from? This is a little calculation from our global forest model, and you see the darker the spots are, the more energy content in the biomass that is growing there can be taken out. So we see that mainly the tropical basins provide a lot of intensity here, but also eastern parts of the US, for instance, and other countries like Russia do it just by its sheer dimension. However, we have the next problem that the development of the forests following certain scenarios might look like this. These are the upcoming 20 years here, and we zoomed into the Congo Basin to the left side down here, and into Southeast Asia to the right-hand side. So actually where these potentially biomass can come from, we have the problem that we are actually losing the forest if we talk about a forest-based system. Okay, so this gets me now to my suggestion and with respect to sustainability, and this is an approach that is actually sounds quite simple. It's to use certified forest management area in order to supply a sustainable feedstock. Now, this is also subject to discuss whether we can equal certification and sustainability, but scientifically speaking, the literature says yes. Okay, so this is our assumption, and as I said, it's only one way forward. And for those who don't know, there are systems like PEFC, the program for the endorsement of forest certification systems, which is kind of an umbrella system which endorses, for instance, SFI in North America and CSA in North America. Then there's another system called FSC for stewardship certification, and others that are tree farm and MTCC, etc. Okay, how does this look like here globally? We see that the dominating systems are FSC and PFC, and there has been a constant growth over the last decades, ending up at about 400 million hectares that are presently certified, which is about 10% of the global forest area, which is quite something, I would say, a good start. But from my point of view, these growth rates are not steep enough. If we look at some countries, Canada is leading here in terms of certification, followed by US, Russia, Sweden, Finland, Ukraine. This is the total certified area. If we look at the share of their forest area, we see that actually we are here in a country that is among the top 3 of certified forest area in terms of share of the total area. However, if we look globally, this looks like that. That means 90% of all certification, unfortunately, happens on the Northern Hemisphere. And if we think back, what I've shown you before is that the highest NPP rates and the biggest accumulation of potential biomass that could be used here is not necessarily in the north, but it's in the south and in the tropical areas. Another caveat of this system is that this is the official data you can get, which is aggregated by country, which means you get one number, like one color per country of certified area. And for a decent bottom-up assessment, this is simply not good enough in order to make a decent assessment. So what we did is we tried to create the first global certification map on 1 kilometer resolution. And this was a huge downscaling effort of consisting of 7 steps, which I illustrated here with some maps that we used. For instance, our own forest cover map at 1 kilometer resolution combined with the protected area map by IUCN and UNEP WCMC, combined with a primary forest map and another one, which is a global managed forest map, because we assumed that certification only makes sense in managed forest areas. So what that all gives is this map, which is displayed at our geowiki.org tool, accessible to everybody. The data can be downloaded here. And if we make that a little bit bigger, you see that we have 5 different colors. Green is unmanaged. This purple or pink one is managed forest globally. The blue one is the one we are actually interested in. This is the managed and certified forest. And then there is brown intact and yellow intact and certified. So if we zoom into that a little bit, here where we are in Scandinavia, you see that it is mostly blue, so mostly certified. That fades out towards the east a little bit and towards the south. If we go further south, this is Indonesia. We see that the Malaysian part of Borneo, for instance, has some blue, but that's actually all. And if we switch to the Congo Basin, we see some blue dots in the west, actually, but it's also not a lot. These are actually the interesting areas here. And in Brazil, it's also a sad situation. You have to zoom in even further, and then you see that at the mouth of the Amazon, you have some certification. Okay. This is the basic, and now comes the modeling with which it should be combined. To the right-hand side, you see the biophysical modeling part of the integrated EASA modeling cluster. In the center is an IEM, the message model. We are all interlinked here, and we are basically, for this study, using the GeoWiki, as I just explained, and the global forest model to the right-hand side, but this could be theoretically also extended to the agriculture modeling. And there is the BeWhere model. It's an engineering model which optimizes the sink and source connection through all the supply chain. How that looks like in a scheme is here. On the left-hand side, you have the supply. On the right-hand side, the demand. Then you have different intermediate steps of existing industries that demand the same biomass, and it should be also sustainable in the best case, of course. And then we have to fit in and optimize our new renewable plants or BECCS plants, or we make a mix and say we are looking to combining that, like we did it, with existing coal plants. We do co-firing and provide sustainable biomass to coal power plants. And then, of course, we have environmental constraints, and the question is, where do we place now this optimally, the new field plants? And another input here is very important. So we calculate with the forest model, for instance, what is the potential for sawwood, what is the potential for pulpwood. These are the competitors. We cannot use this because other industry sectors need it. What is the potential for general forest biomass, and what are sawmill residues, which we could use eventually. What is the wood imported to a country? I'm using Finland as a test case here. And then the existing industries we have to consider, like pulp mills, like paper production, and so on. All that needs to be considered. And of course, we need to optimize here the transport. This is the transport road system in Finland, the railway system, and what we can come up with. We're switching to Sweden here is, for instance, a costing map through all these optimization for a certain commodity. In this case, it was a biofuel, just to illustrate you the system, how our engineering model works. And now coming to the results for our test case in the US. First of all, again, the certification map here, we see quite impressively that Canada is quite a bit bluer than the majority of the US. However, in the US, especially where Drax, for instance, in the UK is supplied with in the south east, there is about half of the forest area managed and certified, which means blue. And this is also important for us to source our local sustainable biomass. I have to mention that again, that we are using it in a test case that we took all existing coal power plants and tried to supply them with biomass to reach a co-firing rate of, on average, 20%. And by that, we assumed that we can capture that and put it underground. Okay, we had 4 scenarios of supply potential here. Scenario 1, that includes all US forests, so to say. Scenario 2 provides the feedstock from managed forest only. Scenario 3 is similar to scenario 2, but adds or subtracts the protected area. And scenario 4 is the most extreme one, which puts all sustainability parameters together and reduces the scenario 3 still by certifying. And this looks then like that. If we go from the left upper corner to the, in scenario 1, this is all forest area calculated with our forest model, to scenario 2, which is already reduced. Scenario 3 is further reduced by certification in this case, and then these little triangles show in addition that we cannot access all the certified one because there is also protected area. So these are the 3 steps here, and what we also need to know is, of course, where are the sources of emission, in this case the coal plants we would like to supply with, and the sinks at the same time, because we would like to minimize the transport to the the sinks. In the end, and this is the outcome of our little trial here, you see that in these two columns, the most interesting one is probably to the right, the negative emissions generated by supplying different kinds of sustainability generated biomass to the coal plants. And if we use all the forests, we can generate about 90 million tons CO2 per year negative emissions. And if we go for the most restrictive sustainable scenario, it's down to 1/3. Okay, so this is our way how we would envisage a sustainable BECCS system. And the conclusions here are, well, sustainable BECCS is possible. We have to mention that we have chosen a very conservative approach here, meaning that we used only forest residues, that we used only a maximum of a certain share of the forest increment, etc. So we supply other industries first who are already there. So furniture, pulp and paper, all kind of timber industry is supplied first, and we are happy with the rest. And this was the outcome. Okay, it's extreme, but it's also extremely low in terms of the results. And another thing is important to state that we think certification is a good step to look into for forest-based BECCS systems. We can say that this proof of sustainability has to push forward because we saw that only about 20% of all managed forests in total US is also certified. It does not mean that using biomass from non-certified forest area is not sustainable, but it's not guaranteed. And somehow with the certification, we can assume that this is guaranteed sustainable biomass. The less sustainable biomass is available, the more important becomes this very careful planning. Our model and this complexity of the model and all the input factors and parameters you have to consider have shown this, but we can still create basically the maximum out of what is left over here in terms of negative emissions. Questions are, the ownership structure, will they be all willing to certify their forest and follow certain rules, which means you have to obey these in order to get sustainable biofuel. The method which is provided here can be extended globally because the basic assessment of certification has been done and it can be updated on an annual basis. So we can derive global sustainable forest-based BECCS and negative emissions. And, well, one thing is, of course, we have to act now. My last slide is about action. Please come and discuss this. We have a Cool Forests conference at IASA in September. If you are interested to discuss these things further, which especially concern also the boreal forest, but also the mountain forests, please come and visit us at IASA close to Vienna in September. Thank you very much.